We are using the concept of the output of one machine learning, ML, neural network as input to another deep learning neural network. This approach is known as model stacking, model chaining, or ensemble learning, depending on the specific context and techniques being used. Pradeep K. Suri, author and researcher. Ensemble learning involves combining multiple models to improve overall predictive performance. In this case, you can use the output of one neural network as features or inputs to another neural network. This can be beneficial in various scenarios. 1. Feature extraction and transformation. The first network can be designed to extract specific features from the raw data. These features can then serve as inputs to the second network, which may focus on higher level abstractions or a different aspect of the data. 2. Hierarchical modeling. You might use the output of a lower level neural network as an input to a higher level network to capture more complex relationships in the data. Each network can specialize in understanding different aspects of the data. 3. Transfer learning. If the first network is pre-trained on a large dataset for a related task, you can use its learned representations to initialize the weights of the second network. This can lead to faster convergence and better generalization. 4. Model stacking. Combining multiple models can lead to better predictive performance. By using the output of one neural network as input to another, you're essentially stacking models to capture different levels of abstraction in the data. However, there are some considerations to keep in mind. Compatibility. The output of the first network should be compatible with the input expectations of the second network. This might involve reshaping or pre-processing the data. Training strategy. You need to decide whether to train both networks jointly or sequentially. Joint training might involve optimizing both networks simultaneously, while sequential training might involve training one network and then fine-tuning the second network. Data leakage. If the two networks are trained on the same data, there's a risk of data leakage. It's important to ensure that the data used for training the second network is not the same as that used for training the first network. Complexity and resources. Assembling models can increase the complexity of your pipeline and require additional computational resources. Hyperparameter tuning. You might need to fine-tune hyperparameters for both networks to achieve the best performance. In summary, using the output of one neural network as input to another is a powerful technique that can help capture different levels of abstraction in data and improve overall performance. It requires careful consideration of data compatibility, training strategies, and potential pitfalls. Thank you.